So now let's move on to the education part of the talk. So you are also a lecturer. So how do you prepare for a lecture essentially?
Okay. So I was a lecturer. Now
Yeah,
I'm not. Um, in my case, I was working on a completely different system than where I started because I studied in Italy and the British system is quite different. And I ended up working, teaching on conversional classes. Conversional classes are classes that are open to people that have different backgrounds. So, in computer science, for example, you open masters to enable people that have a degree in physics, biomedical engineer, humanistic, whatever field,
yeah,
they can join the conversional class and take a master in computer science. So when you are explaining complex algorithm or complex problems, and you would like to write the formula on your well, blackboard and
yeah,
show how you solve that formula, or you use I don't know, some analytical approach like solving a linear equation, and you know that the audience and the students, not all of them have or see these kind of basic things that you give typically know to a computer science master class. So the approach has to be different. You have to tell a story. You have to tell a story that gives the idea, the concept. You do need to make a lot of example that um, everyday life kind of examples where you can show that this kind of techniques can be applied. So, give examples where the people can understand, can they might have already lived on the like the ABS example.
yeah,
Everybody knows ABS. Doesn't matter if you are an engineer or if you are a literature, a humanistic kind of guy that study story, whatever. The ABS is a concept that you should know less, and you obviously have tried to drive a car with ABS. So you know the feeling. So I can now represent some particular concept that. So what I was saying is I'm trying to always generate this kind of example and provide these examples and show the problems, how you try to solve these problems with an algorithm. So how you design that as an algorithm, and obviously it's very complicated. Yeah, basically I'm trying to get closer to the students with examples that they have seen, have and show them a different point of view, providing a different intuition about that. And then there is the part you introduce the algorithm, the idea behind the algorithm, the way it works, and trying to make them understand how you can evaluate that an algorithm is better than another, or how you can also, if you get a real world problem, like the farmer with the fox and the goosey
yeah,
grain. Um, how can you approach? What is the process that you should apply to reach a solution? I think that's the best things you can teach to students, right? Especially in these cases. So I give my classes, plus my conversational class was on intelligence, artificial intelligence. So it's a very interesting topic. People are very interested about that. You can always decide which level of abstraction you want to go. But I believe that again, given the definition of intelligence I provide, is that if you are able to look at the problem and try to represent in somehow your way of thinking to solve that particular problem, because you know you can solve this problem and you can
Ah, okay.
understand what is your way of thinking, you can replicate this way of thinking with an algorithm. Okay, and then I give you a bunch of algorithms basically to show you that how they can work and what kind of problem you can solve with them. So if you see a new problem, you should be able to figure out, these problems can be formalized like these other problem and solved with these particular techniques that we know can solve this particular problem. Okay, so that's more or less what I was how I was preparing my class for this particular um, challenge. So this and but that's not very different from doing this kind of interviews or doing presentation in international venues or speaking with a reporter, because even if in an international conference you might expect everybody is an expert in robotics. Again,
Yeah.
robotics means many different things, right? So there might people be expert in control, people expert in computer vision. So although we are working on the same area, let's say,
Yes.
our interests and specialization and expertise are different. So when
Yeah.
you talk about your own work, you want to, there is some things people will know, some things you need to express, and typically you have very little time to express. 6 months research or 1 year research, you have 20 minutes. Okay, so you really needed to go be very crisp in what you're saying, trying to explain as much as possible. And most of the time, that means you go through a high level kind of overview,
Yeah.
explaining those 2 or 3 concepts that are particularly interesting for you, and then you will show, here is the global picture. And here there are these elements, and I'm working on these elements. And now you know why I'm working on these elements, because this is the global picture, and if you wanted to solve these problems, you needed to solve this problem first. And this is the way I would solve this problem, and that's why I'm using this approach, because it fits this global picture that I drew at the very beginning, right? So it's always for me is always a top-down kind of approach.
So, focusing more on the high level concepts and not going into a lot of details, because then it can get easily complicated. Also, it must be really a challenge to teach to an interdisciplinary kind of a class because of the different backgrounds. So it makes sense to keep it a bit more high level.
Yes, exactly. So in 1 hour class, you cannot really reach too much depth. So what you do, you do homeworks, you provide notes, you provide books or chapters of books in order that people that want to go deeper can go deeper in, and people that have background limitation can do some exercise to improve that limitation, or to recover from a particular lack of knowledge.
Ah, okay. Yeah, and how do you structure your courses? So, for example, maybe an artificial intelligence course that is targeted towards an interdisciplinary class. How do you structure it? So, uh, what would be the
Um,
topics that you'd keep in the initial stages and at the end stages and all those things?
well, my class was quite similar to many of the classes you can also find online, or many different courses, where you first provide an example, definition of AI. You provide examples like game theory, like TikTok kind of games, or Power 4 or Battleship, this kind of AI games that we know
Yeah.
that. You provide an insight on how they can be solved, and then you go for research techniques. basically, like graph, trees. This comes the representation part, right? You need to represent that, and one way is graphically by using graph of trees, that you understand how the system moves, right? Constraints and stuff like that. Then you go for the different kind of games where you have adversarial games. So there is another user. Now you have to take into consideration what the user will do. Their user, the then you have machine learning. So you try to show that you can design an algorithm that, because search is like an algorithm that takes data or states and evolves the system by replicating the state with an action, right? And so it has a
Hmm.
set of
Yeah.
action, it's a tree out of it, or a graph. In machine learning, you have a set of data and you try to extrapolate something out of it, learn
Yes.
something. So you need to infer, to make the inference of be able to infer from the raw data some knowledge which is related to this data, right? You can get from this data. And there are different ways of doing it: supervise and supervise, reinforcement learning. So you present an overview, you show cases where this can be done, what are the limitations of each system, and typically, it comes here deep blue, the chess program, and you show that part was search, part was it was obviously an adversarial system. um, you can show that there is heuristics that have been encoded within the system, because there is a game, you have rules, and you can encode some heuristics. There is a part where there is a data set of opening or closure that you can pick and they will work. There is the middle game where you need to do search and you can learn how to do this search. Okay, and then AlphaGo, in another game, very very complex, how they could learn how to decide what kind of action, and to decide if that action was leading to a win or a lose. And there obviously system become very complex, because typically it's not just one approach. It's not
Yeah.
just you know path planning kind of algorithm where you have a tree and then you solve it with an A star or whatever. It becomes a complex things. Is You start seeing heuristics, and then search, and then learning, and then there is minimization of some cost with path, and then there is some decision making things coming in, and different model for learning, different functions and stuff like that. So becomes very complex, very easy. So what you want to do is show different parts, and you know if you have introduced all these the most important techniques, you can show, see, in this real application where we try to solve this real world problem, we got
Hmm.
the combination of these techniques combined with these other techniques we already know, right, in this way, because we have these techniques that brings this particular benefit with these other techniques that have this particular benefit, or have some limitation that these other techniques can take care of. So that's the idea of how you present, in order to make it more interesting, to show some real applications that came
Yeah.
out, and to to the students to know, to be able to talk about these systems, because are quite famous, and they should have an overview of these systems clear in the, although they might not understand all the process, or all the different components.
Okay, so essentially you try to focus more on making it interesting by giving them the applications that these algorithms have, and then also in a way connecting to what they already know, so it kind of sticks with it kind of stays in their memory as well, because you know the you're kind of you exploiting the nature of the neuronal arrangement in their brains to kind of help them learn better. Yeah. So also talking about education, what do you think about the online course platforms like Coursera, Udacity, and all those things that are existing?
Well, when I was a student, obviously we didn't have this, and the student, the studio was basically um, following lectures, and then go in the library and open the books, your notes, and study them. Obviously, the multimedia way of getting information now is very useful, and these classes can be very focused. You can, choose the courses you want to do, and y- there is the way to interact because it's not anymore videos online. You can comment, you can directly
Yeah.
talk with the lecture. You can also have live sections where you can interact and ask questions. So there definitely is a very useful and powerful mean to learn. I'm using it. During my PhD, when I had
Ah,
to learn about new stuff, I would have also take advantages of some lectures online. I have to say, for example, the AI class taught by Winston, I look at it before starting teaching my own class because
okay.
I knew he was a great professor, very nice to, very nice, kind of casual kind of a conversation that was leading to the point, and I like that particular style, so I really enjoy the classes. Another very popular in our field is underactuated robotics,
Okay.
and again, the Drake, the lecturer is really known for being an amazing lecturer, and explains again all these concepts in a very easy way with a lot of graphical aids, and is let you combine things together, and obviously when the class is also very interesting because kind of fit your interest,
Yeah.
it's easy also to follow. But I believe these guys are able to teach you these kind of topics also if you don't have the background.
Okay. Okay. And also there is a fundamental difference in the way courses are structured in a university. For example, there's a uh, 1.5 hour lecture, and then there's also an exercise session which is probably also of 1.5 hours. And then in Coursera courses, it's or any online courses, the structure is different. So there are like very small 5 or 10 minute videos and then an exercise. So the structure is different. Which of the following approaches do you think is a better way of learning, for example, for a technical field like robotics and or artificial
Well,
intelligence?
right now we are actually in a period where the education, the traditional education has changed, right? Because now we are doing a video online lecture. My colleagues are doing everything online and remotely.
Yeah.
Um, I really don't know. It depends. If you are a student full time, then being in at university 5 6 hours a day with your colleagues, and growing with all the colleagues at the same rate more or less, because you
Yeah.
can help each other. I think is very very important. And at the university, actually, that was the main point, because you're a kid and you want also to have fun, and
Yeah.
and plus is one thing. Well, I did math and computer science, right? So all my colleagues were nerds and geeks, and it makes sense. And you start making jokes about things that you have learned in class, right? Like some particular fancy name for a theorem that sounds silly, or the fact that you think about binary representation instead of decimal anymore, or just the thing that if you're a computer science and somebody asks you the number and tell you like ring me, so send me a message so I know your number, you send a message with ping, right? Because you ping that's exactly what the ping is, right?
Yeah,
So it becomes part of your way of acting, or way of
yeah,
joking, way of interacting with people, because you're a nerd, obviously, but also because you start understanding, you metabolize this concept. You can extrapolate this concept from the standard application and applied it on your everyday life. You can discuss about those, right?
yeah,
You can have names associated to techniques. Is a Derapustin kind of phenomenon, right? If you know the name, you have power over it, right? And if you can have a concept that is you get you can label a concept, you're able to talk about that in front of a beer with your friends at the pub, and by talking it, you also see if you can elaborate on top of it, if you actually grasp the idea in a way that you can elaborate. Okay. And discussing with other people, you can see different point of view, they might have understood something different. So I think this part of interactions that I prefer to be face to face, because
yeah,
I'm quite old, so I get um, uh, I grew up, in the countryside where the kids were going to play football in the park, and you sweat and you talk and you laugh all together. So the virtual interaction, although I'm using it constantly, I still prefer the old-fashioned way. With all the, obviously, in this situation, I also will adapt to maintaining social distancing and all the things, because I don't want to jeopardize friends or family. But yet, I would prefer to stay 2 meters away from a person and still laugh and discuss than
yeah,
stay
yeah,
talking with the camera. And during my period at university, I think the social group, this aspect that I done, because I was at university basically from 9 to 6 all day, having lunch together, that help also support my education in a, in many different ways. So yeah, if you are a young, I mean, if you have full-time students, I would suggest you go to the university, do it.
yeah,
If you have the means, obviously. Um, if you are like a part-time student, in a sense that you are a worker and you needed to just learn some concept, or you want to, out of curiosity, you wanted to learn something new, then that would work. It would satisfy your curiosity, would provide you a title, and you can learn new stuff. So the goal is accomplished. But again, you lose part of this interaction. But if you are maybe a worker, this interaction you have at the work side, right? So kind of it's good to have it, right? I would suggest
yeah,
for a kid to go to school, that because social interaction, in my opinion, is quite
yeah.
important.
Yeah, so both have their each of them has its own advantages and disadvantages in a way. So as you say, for quick learning, maybe online courses are quite good because they are you can do it on your own, but then they don't have this social interaction and actually talking casually about the concepts with your friends kind of environment, which the universities give you a better option to, because you can also interact with the professors and your peer group in a way.